Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Data Strategy, Collection, Labeling, and Cleaning. Data strategy encompasses the meticulous processes of collection, labeling, and cleaning, each integral to the successful deployment of AI systems. These processes form the backbone of any AI development lifecycle, specifically during the planning phase. A robust data strategy ensures that the AI models are trained on high-quality data, which is crucial for their performance and reliability. Data collection is the first step in this strategy. It involves gathering relevant data from various sources, such as sensors, databases, web scraping, and more. The importance of data collection cannot be overstated, as the quality and quantity of the data directly affect the AI model's performance. For instance, high-quality image data can significantly enhance the accuracy of computer vision models. However, collecting data is not merely about amassing large volumes. It is about obtaining diverse and representative datasets that accurately reflect the problem domain. For example, in developing a facial recognition system, it is essential to collect images from a diverse population to avoid biases and ensure fairness. This practice aligns with ethical AI principles and helps in building models that are equitable and unbiased. Once the data is collected, it needs to be labeled. Data labeling, also known as data annotation, is the process of tagging or classifying data to make it understandable for machine learning algorithms. This step is crucial because it converts raw data into a format that AI models can learn from. For example, in a supervised learning setup, each data point must be labeled with the correct output, such as tagging images with the correct object labels. The quality of labeling directly impacts the model's accuracy. Inaccurate or inconsistent labels can lead to poor model performance, as the model learns from these labels. Therefore, it is essential to employ rigorous quality control measures during the labeling process. Techniques such as cross-verification by multiple labelers and the use of automated tools can enhance the reliability of labeled data. Data cleaning is the next critical step in the data strategy. It involves detecting and correcting errors and inconsistencies in the data to improve its quality. This process is vital because real-world data is often messy, containing noise, missing values, duplicates, and outliers. For example, in a dataset of customer transactions, there may be missing values for some transactions, which can affect the model's performance if not handled properly. Data cleaning techniques such as imputation for missing values, removal of duplicates, and outlier detection are employed to address these issues. Moreover, data cleaning is not a one-time task. It is an ongoing process that requires continuous monitoring and updating to maintain data quality over time. The interplay between data collection, labeling, and cleaning is essential for building robust AI models. For instance, consider the development of a natural language processing model for sentiment analysis. The data collection phase would involve gathering text data from various sources, such as social media, reviews, and forums. The labeling phase would require tagging each text sample with the correct sentiment label. The data cleaning phase would involve pre-processing the text data by removing noise, correcting spelling errors, and normalizing text. Each of these steps is crucial to ensure that the NLP model is trained on clean, accurately labeled, and representative data, leading to better performance and generalization. Incorporating relevant statistics can further substantiate the importance of a robust data strategy. According to a survey by Kaggle, data cleaning and preparation are the most time-consuming tasks for data scientists, taking up to 80% of their time. This statistic underscores the significance of data cleaning in the AI development lifecycle. Moreover, a study by IBM estimated that poor data quality costs the U.S. economy around $3.1 trillion annually. These figures highlight the economic impact of data quality and the need for effective data strategies in AI development. Examples from real-world applications further illustrate the importance of data strategy. In healthcare, for instance, the development of AI models for diagnosing diseases relies heavily on high-quality medical data. A study on diabetic retinopathy detection using deep learning models demonstrated that the performance of the model was significantly influenced by the quality of the labeled data. Similarly, in autonomous driving, the success of self-driving cars depends on the quality and diversity of the collected data, such as images and sensor data from different driving conditions and environments. A well-defined data strategy also has implications for AI governance. Effective data governance ensures that data collection, labeling, and cleaning processes comply with ethical standards and regulatory requirements. For instance, data privacy regulations such as the General Data Protection Regulation impose strict guidelines on data collection and usage. Organizations must implement measures to ensure that personal data is collected and processed in compliance with these regulations. Moreover, ethical considerations, such as avoiding biases in data collection and labeling, are crucial for building fair and transparent AI systems. In conclusion, data strategy is a critical component of the AI development lifecycle, particularly during the planning phase. The processes of data collection, labeling, and cleaning are interdependent and collectively contribute to the quality and performance of AI models. High-quality data collection ensures that the data is representative and diverse, while accurate data labeling transforms raw data into a format suitable for machine learning. Rigorous data cleaning processes address errors and inconsistencies, enhancing data quality. Real-world examples and statistics underscore the significance of a robust data strategy, highlighting its impact on model performance and economic outcomes. Furthermore, effective data governance ensures compliance with ethical and regulatory standards, fostering the development of fair and transparent AI systems. Therefore, investing in a comprehensive data strategy is paramount for the successful deployment of AI systems. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.